Hello everyone. In last class we were discussing about basic characteristics of amines. We have compared pKb values of several amines. Lower the pKb value, greater will be the basicity, right? And greater the Kb value and greater will be the basicity. Let us compare this basicity of these amines. First one is methenamine, and also I have discussed in previous class that the basicity of simple amines, that is like primary amines or secondary amines or tertiary amines, greater compared to ammonia, and basicity of aryl amines is less compared to this primary or secondary or tertiary amines. Why it is so? And I have also mentioned that this is because of the several few factors like inductive effect and solvation, as well as one more is steric factor. Now, if we compare methenamine and last, which is N-dimethyl aniline, or I will just compare with the simple aniline, and here it is methenamine. Methenamine is nothing but a primary amine, right? And here it is aromatic amine. Now, pKb value of this is very less, here it is very high. Lesser the pKb value, greater the pKb value, greater the basic strength, right? Here, because of the presence of a plus I effect, the cation formed is stabilized. But here what happens? Due to the resonance, that lone pair of electrons are not easily available for stabilization of cation formed, or it will involve in the resonance in benzene ring, and hence it shows a greater pKb value and hence a lesser basic strength. Or else, if you compare methenamine and N-dimethyl or N-ethyl ethanamine, so here it depends several other factors also. I will explain later, or I'll compare these two, or N-diethyl ethanamine and methenamine. Here methenamine shows 3.38 and N-diethyl ethanamine shows 3.25. Right? Here in N-diethyl ethanamine, you can observe greater the inductive effect compared to methenamine. So, electron donation from the so all the hydrogen atoms are replaced. Or else, if you compare primary amine, secondary amine and tertiary amine, in primary amine you can observe only one alkyl group. In secondary amine you can observe two alkyl group and N and here H, right? In secondary, and tertiary, all hydrogen atoms are replaced by alkyl group. Hence, in gaseous state you can observe greater basic strength in case of tertiary amines, but it is not the same in case of aqueous solution. There is some differences there in the basicity. That is, in gaseous state it shows one order, that is tertiary shows greater basicity than secondary and primary, but not the same in case of aqueous solution, that we will discuss later. Okay. So basicity depends upon the ease of formation of a cation, right? As I said. And this cation formation takes place by accepting the protons. First one is basicity of alkyl amines versus ammonia. Alkanamine versus ammonia. Here R and H2 NH2 on reaction with hydrogen. We already studied this reaction. What happens? Ammonium salt formation takes place. R and H3 plus and NH3 plus, and if there is HX and X minus. And if we take ammonia, NH3 and lone pair of electron, which on reaction with the which on protonation, right? Which on protonation. Again gives 4 hydrogen atoms. Here also you can write like that, like this only. Hydrogen, hydrogen, hydrogen. It's positive center. Right? Now, in gaseous state, what happens? In gaseous state, due to electron releasing nature of these alkyl groups, here first, because of the presence of this lone pair of electron, it will undergo protonation and it acts as a nucleophile. It reacts with the electron deficient center. Now it results in the formation of a cation, right? Deficient cation. And because of the presence of this alkyl group, the electrons will move towards nitrogen and makes the unshared pair of electron is more available. That is, here unshared pair of electron is present because of the presence of this alkyl group. This alkyl group donates the electron and more electron density increases there in nitrogen atom. More number of electrons are available for the donation or for the reaction with the proton, and hence forms a cation. And this cation is stabilized because of the presence of alkyl group, because of the positive I effect, plus I effect, that is electron donation or electron donating inductive effect. And what happens in case of ammonia? Now, in ammonia, ammonium salt formation takes place. Here it is substituted ammonium salts takes place. Here just ammonium salt formation takes place. And here you cannot observe any electron donating groups, right? And in a cation also you cannot observe any electron donating group, and hence less electrons are available for protonation, as well as here it is compared to substituted ammonium salt, it is less stabilized. Here it is stabilized by inductive effect. Here there is no inductive effect. Hence, as I said, alkanamine shows a greater basicity compared to ammonia in gaseous state. And one more thing, if you compare, I have already explained, it is primary amine. If you take secondary amine, one more hydrogen, if I replace by R group, then we will get more electrons, or electron density increases more because more number of electron donating groups are attached, right? And hence inductive effect is a more, plus psi effect will be more, and basic strength increases. Or else if we replace all hydrogen atom by R, that is alkyl group, then what happens? then again basicity increases, right, due to the availability of a more number of electrons, and cation formed is highly stabilized, right? Hence in gaseous state, I am mentioning in gaseous state, tertiary amine shows greater basicity, after that secondary, then primary. Remember, and at last is ammonia. This is basicity order in gaseous state. Now, what is the basicity order in aqueous phase? In aqueous phase, along with the inductive effect, one more effect also affect the basicity of these amines, that is solvation effect. And if one more thing is, if there is different alkyl groups are attached, then steric effect also influences the basic strength of amines. If I in aqueous phase means in water, right? Here ammonium salts stabilized by both plus I effect and solvation effect. Okay, you already studied what is solvation. Now, greater the size of the ion, lesser will be the solvation. Now, if you compare primary, secondary and tertiary amine, which one is of greater size? Of course, tertiary amine, right? So, in case of tertiary amine, inductive effect will be more, but solvation effect is less. Because of less solvation effect, there is solvation effect. If we take water, it will not easily bond with the hydrogen. In tertiary amines, what happens? 3 methyl groups are attached. In case of trimethyl, okay, 3 methyl groups are attached, and it will not undergo solvation easily because there is no hydrogen atom. Hence, greater the size of the amine, lesser will be the solvation and lesser will be the basic strength. And now, basic strength in gaseous state, if we take alkyl amines, it follows reverse order. Okay, and one more thing, if there is bulky groups are present, then order becomes different, and we cannot predict easily the basic strength in case of aqueous state. Okay, that is that is ammonium salt. I have NH2. First NH2 will be there, NH2 and R, primary amine, abstract one proton and will becomes ammonium salt. I have already written in a gaseous state, right? And if we take secondary, then what happens? two alkyl groups will be there, and here it is attached to hydrogen atom. And in case of tertiary, R and one more R group and one hydrogen, and it is cations, right? Now here it will easily undergo solvation with the water, OH2 group. It will. Here also same, OH2 water. Here also again undergo solvation with the water, right? And here again it will undergo solvation. Here also it will undergo solvation, and here it will undergo solvation. Now solvation will be more in case of a primary, and next is in case of secondary, and last is in case of a tertiary. And hence order of basicity is primary is more basic than secondary, and next is tertiary in case of in presence of in aqueous phase. In gaseous phase tertiary, secondary, primary. Here primary, secondary and tertiary, right? This is about in gaseous state. Greater the stability, greater will be the basicity. Here stability is greater in case of a primary amine due to solvation, right? Next is when alkyl group is small like CH3 group, then we cannot observe any steric factor. But as alkyl group, as size of alkyl group is increases, then it then increases the steric hindrance, or it will affects on basicity because of the presence of a bulky group. Okay, because of the presence of a bulky group which decreases the basicity, because it hinders the electron hydrogen bonding. In case of small groups like methyl, or in case of ethyl, that is C2H5, if you compare basicity of these, if more number of these groups are attached, which hinders the hydrogen bonding, and hence which decreases the basicity of amines. We will discuss basic strength of few amines by taking example, that is C2H5 and twice NH2. You cannot predict easily because NH, because it influences here, influence of steric hindrance also there, as well as solvation effect there, and inductive effect. But because it is in aqueous state, mainly solvation effect, and because of the bulkier group in hindrance, steric hindrance, hydrogen bonding will be less. And next is C2. Just remember these two orders. Rarely they ask, but still if possible remember C2H5 and NH2, and last one is ammonia. Ammonia is less basic, however there is no inductive effect as well as solvation effect. And here it is CH3 in case of methylamine, twice NH is, next is CH3 NH2, next is CH3 twice, thrice N, and last is NH3. Okay, this is order of basicity in case of bulkier group, that is in case of ethyl and methyl groups attached to nitrogen atom. So here you can see more number of methyl group, inductive effect will be more, but it is bulky group, solvation will be less. Right here solvation will be more. Hence all three factors will influence the basic strength of amines. Let us move to the next topic, that is aryl amines versus ammonia. I have already discussed aryl amines are less basic compared to ammonia. Aryl amines versus ammonia. Ammonia is highly basic compared to aryl amines. We will discuss the reason for this. If we take aniline as example, the lone pair of electron present in nitrogen will be in resonance with the ring. That is, we know the resonance structure. It is negative charge, double bond, NH2 plus. Next what happens? This electron shifts over here.